Section 1.2 is on angle relationships and similar triangles. So let's get our information down before we look at some problems. So the first definitions that we get are about vertical angles. And vertical angles are those that are made if you have an X. So these angles in here, right here, this one and this one are vertical, and they have exactly the same measure. Now, when you have parallel lines, we should know those go in the same direction. They'll never intersect, so they're the same slope. And if you cut them with a transversal, you get all kinds of different angles. So here I've got two parallel lines. I've got a transversal. Inside between the two parallel lines, I've got alternating, so they're on either side of the transversal, alternate interior, and those are equal. If I've got on the same side of the transversal and inside, they're same side interior, and they're not the same, but they do add up to 180. So that's another relationship. And then also, if you have the same place, like here and here, so I'm above the parallel line and on the right side of the transversal, those are corresponding and they are equal. So those are the relationships that we need to remember. We also need to remember that the sum of any angles in the triangle, if you add them all up, it's 180 degrees. And inside a triangle, we classify triangles by angles sometimes. So we've got acute triangle, right triangle, obtuse triangle, or by the sides. How many sides are equal? If they're all three equal, they're equilateral triangle. If two of them are equal, we have isosceles. And if none are equal, we have a scalene. So those are ways to classify triangles. We can talk about congruency with either angles and sides. If they're congruent triangles, that means all the angles have to be equal and all the sides have to be equal. So they're going to look exactly the same. Similar triangles, the angles are equal, but the sides are proportional. So this one looks like the angles are the same, but this is a mini version of this one, and that's what similar would be. So I think that's our information to get, and let's go look at our problem set. All right, so our first question, you have this diagram and you're supposed to fill in all these. Well, I've already done that, but I think maybe we need to look at that also, what it looks like to start with. So let me go here, and on this one, I will show you the blank one. So what you're given is you're given this angle, and this angle, and that's all you're given, and you're supposed to fill in all of the rest. So that's why we have to know what's equal, what's not. This 60 degrees and this angle 7, those are alternate interior, because here's your parallel lines and these are on either side. So that means 7 has to be what? 60 degrees. So we could fill that one in. We know that number 3 is opposite 60, and it's going to be equal to 60 degrees. Once you know 7, you can get 9. It's also 60 degrees. So you could fill all those in that way. Then you can think about if this is a straight line and this is 60, what does this one have to be? They have to add up to 180. So 180 minus 60, that'll have to be 120. If we go back and look up here, we can see those two have to add up to be 180. 60, 60, we talked about that. This one's 63, so this one's 63. If this is 63, these two have to add up to 180. So 180 minus 63 gives you the 117. All right, so we know this one's 63 because it's alternate interior to this 63. See how we're just going around? Now, if I know this is 60 and this is 63, can I figure out this one? These three are making a straight line. So 180 minus 63 plus 60 is going to give me the 57. Same idea down here. Let's see. Now we figured out all those. Those are vertical. So I think we've gotten them all. And you could go through that pretty slowly if you need to. But that's the idea of what you're doing. All right. Now number 2. Number 2 says name the corresponding sides and the corresponding angles. And what I find is helpful to do is to draw this second one so that it's facing exactly the same direction. So I did that. I turned it around so now I can see better. So the side HJ corresponds to QR, and you want to put the letters in the right places. HK, so going down, is the same as QS. JK, so we're starting at this point, JKRS. Angle H is with Q, J is with R, and K is with S. So I think it's really helpful to redraw that. It helps me see it better. All right, on number 3, says find the measure of the marked angles. Well, remember, these are vertical angles, so they have to be equal. So we just set them equal, and then we solve it. So if I subtract 40 over here, I get negative 32. So I have, and then if I subtract 8x this way, I've got negative 4x. Divide by negative 4, and I get x is 8. Then I plug in 8 to both of them. You should get the same number. If you don't, something's wrong. So be sure you watch that. Number 4, the measures of 2 angles of a triangle are given. Find the third. Remember, they have to add up to 180. So add up the 2 you're given. That's 147. Subtract from 180, you get 33. Number 5. Now, same idea. I redrew this triangle so that I could see it better. And I know that that's 90 and that's 40, so this one has to be 50. So I do know that. And then angle Q up here has to be the same as this one, so that's 40. Angle B has to be, we said we figured it out, it was 50. And angle P then matches B, so it will be 50. All right. Find the unknown angle measures in each pair. All right, these are similar triangles. So if this is 30, this is 30, 90, 90, what do these two both have to be? 60, because 90 minus 30 is 60. They all have to add up to 180. So 60 would be there. Number 7, you can watch an author video for that problem if you want to, but I've given you directions here as well. So we've got similar triangles. That means the sides are proportional. So 9 has to compare to 27 right here as B compares to 30. So you write that proportion, and remember, with proportions, we can cross multiply. So 27B, that's there, is equal to 9 times 30, which is 270. So B has to be 10. I can do it again for A. 9 has to compare to 27 as A compares to 27. So what does that mean? A is going to be 9 as well. All right, so similar triangles. Number 8, I think I did some drawing here. A tree casts a shadow that's 32 feet long. At the same time, the shadow cast by a vertical pole that's 9 feet is 8 feet. Find the height of the tree. So they're telling us we've got 2 similar triangles, and we've got 32 here and 8 here. Those are the same types. Those are the proportional sides. 9 goes with the tree height. So we can say 8 compares to 32 as 9 compares to the tree. Cross multiply, 288 equals 8t. Divide by 8, so the height of the tree has to be 36 feet. All right, let's look at number 9. On a photograph of a triangle triangular piece of land, the lengths of the sides are, and they give us 12, 15, 21. The shortest side of the actual piece of land is 300. So it's going to have to compare with this 12 because that's the shortest. Let's see. And find the pieces, the other two sides. So we just do two similar proportions. So 12 has to compare to 300 as 15 goes to x. And so we do our cross multiplying and divide, and we get x is 375. And then if we do the thing for y, we've got 12 compares to 300 as 21 compares to y, and we get y is 525. So same thing that we were doing, similar triangles. And that should take care of section 1.2.